For this video, I already prepared an initialized project so we can immediately start coding together. You can find a link in the description. With the project open in Visual Studio Code and all the dependencies installed using Yarn, let's talk about what's inside the project folder. We have a data folder which contains a few example assets taken directly from the Detonated Tunes collection by the Degen Tunes. I want to thank the whole team for letting me use them. The out folder is where our generated token will be saved after creation, and the src folder contains our TypeScript file. Before we start coding, I want to mention the library that we are about to use. It's called GIMP, JavaScript Image Manipulation Program, and this library comes in two flavors from two different authors. The original GIMP library is written in pure JavaScript, and it comes with a lot of built-in extensions. The one that I'm actually using in my repo is GIMP Native. This other library is a C++ re-implementation of the original library, which is extremely fast thanks to its native nature. It lacks some features from the JavaScript version, but it's blazing fast. So whenever you don't need one of the missing features, I highly recommend using the native version. GIMP Native used to support Linux and Windows only, until about a month ago when I opened a PR for macOS support while I was working on the Degen Tunes detonation project. The author has been kind enough to review it and merge into his project, so macOS is now supported out of the box. That said, let's play with some images. Here is a very basic example in order to understand how the library works. At the top here, we have the import statement for both GIMP and GIMP Native. If you have any troubles with the native version, feel free to use the other one. You can simply remove the entry in the package.json and reinstall the dependencies. Everything will work exactly the same, just a bit slower. Next, we have a bunch of variables for the layer names. These will help us later. Then, we have an asynchronous function called main. This function is the main runtime of our script, and it's called as the last instruction in this file. Inside the function, we have the declaration of a background variable which uses the GIMP API in order to load the background layer as an image. It's really important to notice the await here, because the read function returns a promise, and using the async await syntax makes the code much easier to read. The next instruction is the token image definition, which is not always needed, to be honest, since you can also use the background layer as the initial canvas. But here I wanted to show you how to generate a brand new image of 600 by 600 pixels. Below this, I'm calling the function blit on our token image. Let's take a quick look at the documentation. This function takes the token image and places the background on top of it, taking care of any transparencies. The two numbers here are the coordinates in order to offset the compositing if needed. In this case, we aren't applying any offset, so the two layers will be perfectly aligned. The last line in the function will simply save the image to the output path. Now let's run the code and see the result. In my terminal, I type yarn build, and then I also add a yarn start to run the code immediately after the build. The result will just be the background, since we created an empty image and placed the background on top of it. Let's add something more to it. Let's add a body layer. In this case, it's just gonna be a floating head. I duplicate the read instruction and also the blit one. Let's save, build, and run. And here is the result. Cool! This can be replicated for as many layers as you need. Now let's add a hat so I can show you an interesting trick. Of course, an art engine would load and put the layers together automatically, but here I want you to understand how it works under the hood. The output looks fine, so we can say that these layers are production ready, right? Nope! There is an issue that you may have already identified, but let's make this more obvious by applying a different body layer. And what a mess! The zombie body looks very bad here. Look at the tentacles on the side. It's clear that these layers do not work well together. So, what can we do about it? There are multiple solutions. For example, you can adapt all of your layers so that they will always look good together, but this may be visually boring. Also, you can tweak your generation code so that some layers won't be put together into the same token, but this might mess up with the rarities. Or, you can think a bit out of the box and be creative. Here is how I fixed this with the Detonated Tunes collection. Imagine a real scene with that hat and the tentacles put together in that exact position. The reason why this looks off here is because of the lack of depth. With this implementation, the hat can be placed at one single depth level altogether, and other elements can either be behind or in front of it. But this is not how it works in real life. Parts of the hat, for instance the upper part, would be in front of the body, while this part here would be on the back, so tentacles should be in front of it. But how can we achieve this? The solution requires a change in both the layers and the code. So, first of all, we have to split the layer in two. Here is the part of the hat that should stay behind the body. And this section here is the one that must stay in front of it. If we merge these two layers together, we will recreate more or less the original hat, except for this section here that looks a bit weird, but you will understand its purpose in a second. Let's update our code in order to use these layers instead of the full one. I load both layers. And use the bleed function before and after the body layer. Now let's run this. Oh, now we are talking. Look at the tentacles here. They are coming straight out of the head, and the depth is much more accurate. Also, on the right side, we have a side effect that coincidentally works pretty well. The tentacle stays on top of the rim here, but then it's behind the top section. This works since the hat is melting, so it's okay that the tentacle passes through. But what about the weird yellow section on the back layer? Well, that's needed in order to fill the gaps on the sides with all the possible body shapes. Let's revert back to the white body. It's hard to see it with a gray background, but this section here is actually an empty gloss. So we should see through. Let's remove the background so we can see it better. With more contrast, it's clear that the hat is filling the gaps, otherwise we would see the background there. Using this trick, I've been able to create effects which were impossible to achieve with previous methods, and that's why my plan is to include a way to do this in the next version of the art engine by the Ashlip's lab. But there's one more tip that I want to share with you. GIMP has a lot of tools that you can use in order to manipulate images. It's not just about putting layers one on top of each other. For example, here is how to change the hat color completely just by adding a few lines of code. We can perform any actions on our layers before using them. So let's apply a UE tool from the color extension. This tool allows us to set an offset number in degrees in order to rotate the UI of the image. 260 will turn our yellow hat into a vibrant pink one. And we also have to do the same for both layers. Let's check it out. Here it is. The possibilities that you have with these kind of libraries are endless. And my ultimate goal is to provide you with a new art engine that will make it super easy to customize its behavior and take advantage of libraries like this.